Hello everyone, spring is here and it's soon time to get started with the pool and starting the circulation and preparing it for the summer season. So I thought this would be a good time to show you how I created my pool monitoring system and how I connect it to the Magic Mirror, of course. Welcome and hope you enjoy. So in this first part, I will be looking at the sensors for water quality. I will be using a pH sensor and an ORP sensor. The second part, I will look at the level sensors, the water level sensor, and also how to control the pool filling with a water valve. And in the last part, I will be adding some temperature sensors and also do some integration with Teldos and to control the pump and chlorinator system. Looking at the sensors for the pool, there's quite a lot of sensors to choose from. I like to use the sensors from DF Robot, and of course I will put links to the ones I use in the description. DF Robot has a lot of water quality sensors and quite inexpensive sensors, but are really good in these kinds of applications. So I was first looking for a sensor that could measure the chlorine content of my pool water as you do with the test strips and so on. But I couldn't find one that was not too expensive. So I looked at other different types of sensors for checking the water quality. And I ended up with two of these sensors, and I will go a bit more into details of those. The first sensor I selected was the pH sensor, and DF Robot have a couple of different ones, but I selected the Pro version 2. And the main reason for that is because it's very easy to interface with and it has also a long probe life. So this one you can leave in the water for 24/7 and it will last, they say at least half a year, but I had mine for 3 years and it's working fine and very little calibration. It outputs a voltage of 0 to 3 volt in the range of 0 to 14 pH. So it's easy to calculate the pH value and it has an accuracy of 0.1 pH. So that's very good for an application like this. It's a very good sensor. It also includes an interface board, as you can see in the picture here. So just connect, calibrate, and start to use. The second sensor was a more bit difficult to select, but I ended up with an ORP sensor, and that stands for oxidation reduction potential. Also this one from DF Robot. And the reason for that is that I found that this is the recommended for monitoring the water quality. And I've also been using this for a couple of years and it has been proven to be very accurate in terms of telling me if the water is okay or not, if I need to add more chlorine or if there are other problems. So it's proven sensor for me, and it's also very easy to interface. Same type of board included, conversion board. It's powered by 5 volt, and it outputs a signal from 0 to 5 volt. And the measuring range for ORP is actually in millivolts. So what you want to detect is what is possible to detect is between minus 2 volt and plus 2 volt. So that will be recalculated, and it's a bit complicated formula, but they have it on their page in the example, so it's really just to copy that one, and it will recalculate your measurements to millivolt. And in my case, a good water quality is between 600 and 700 millivolt or above. And if it goes below 600, then it starts to deteriorate. And if it's downwards 300, 200 millivolt, then it's really bad quality. And that works excellent for me. Since both of these sensors are, I forgot to say that the pH sensor can be powered with 3.3 volt if you want. In my case, I would power it with 5 volt. So since both sensors are analog and we really dependent on a good reading of the analog signal, I have some bad experience about ADCs on the Arduino, at least on the Nano. It's fluctuating a lot and it's not so stable. So in this case, I decided to use a separate ADC converter. The ADS 1115 is a 16-bit 4-channel converter with I2C interface. And I've been using that in several applications. It's really stable and it's really good measurements, and it's also easy to interface to the Arduino. So that's what I'll be using in this application. Here you can see a simple drawing of the connections, and you have the interface board. It only goes in this case it goes directly into the Arduino, but in my case I will use the external ADC to interface. So having a look at the schematics then. The two sensor boards are both supplied with 5 volt. The pH sensor board is actually good for 3.3 volt as well, but I have 5 volt in my application, so I will use that. And then I take the output signal from the sensor boards and put it into my ADC on channel 0 and channel 1. And the other end of the ADC is a I2C interface that interface directly with an Arduino. So it's simple to connect the two sensors. Having a look at the Arduino program, I will do this in different steps. So the first step is I will just add the sensors and I will upload it, of course, to my Magic Mirror. So I will not go through the details of the Wi-Fi and upload to the Magic Mirror, which is actually a Raspberry, because I've covered that in my earlier videos about Magic Mirror and Arduino. But I use the same way and the same libraries and the same Arduinos actually. It's an Arduino Nano IoT 33. And the first thing I want to do in the setup is that I initiate the Wi-Fi. And I will also initiate the ADC converter. In this one is has a programmable gain. And in this case, I will set the measuring range to 6, internal reference of 6 volt. There are different settings you can use for different accuracy and so on. And then I will pre-calculate two values, the pH factor and the pH offset. And I will go through the calibration of the pH sensor later on. But basically I'm calibrating on two values, a neutral voltage value from the control, the calibration of 7.01 pH, and an acid voltage that I get from the pH 4 calibration. And then I create a factor to see the pH relation to the voltage that I measure. So I will use that factor to calculate the pH later on. And then I also, to get a bit more accuracy, I'm offsetting everything from the neutral voltage, meaning the pH 7, because I don't really care about values that are far from pH 7. It's not applicable to measure pH 4 or pH 10 or something. The pH will vary between 6 and maybe 8.5. So I want to offset everything from the neutral voltage, which should be 1.5 volt, meaning 1500 millivolt. But then depending on the calibration, it will be a bit different. So that's why I'm calculating the pH offset here. Moving down to the main, connecting to my Wi-Fi. And then I will read my pH and RP values every 5 seconds. And I will upload to my Magic Mirror every 30 seconds. So let's have a look at those 3 different. So reading the pH values. I'm reading the value from my ADC. This will be a 16-bit value. I'm reading channel 0, which is the pH. I'm saving this into an array that I will have for keep 10 values to calculate an average, but I'm also saving the current pH value. And here I'm storing the values in my array, and I'm sorting the values. And the reason for that is because I will remove the highest values and the lowest values, and then calculate an average from that. So moving down to the actual calculation here. First of all, I will convert it to voltage, actually millivoltage, and to make it easier to understand and to calculate with it. And I use the library function to voltage here, which is for the ADC. So my variable pH voltage will have the measured voltage for pH. And then I will calculate the current pH value in this case, and that's only for printing. It's only for debugging, so I'm printing it on the console, and then I will actually overwrite it down here. And this is the same type of calculation, but instead I will use my average value from the saved array. And this is what's really interesting, and that I will also use to upload to my Magic Mirror. So here I'm taking my measured value, and as I said, I'm offsetting it from pH 7. So I'm deducting 1500 millivolts, and then I'm also adding the pH offset I had previously calibrated and multiplying with the pH factor. So in the end, this variable here, pH value, will hold my average pH value over. In this case, it will be over, since I'm measuring I think it was every 3 seconds, or every 5 seconds it was, and I'm covering 10 values. So it will take a minute to calculate the average value. Having a look at the ORP function, it's pretty much the same. I'm reading channel 1, also storing it in an array, calculating the average values. But the calculation here is a bit more simple. And the ORP value doesn't need any calibration. So I'm just using the millivoltage that I've received and calculate based on a 5-volt supply, and then I end up with my ORP millivolt value. And that's what I'm returning, and that I will also upload. So moving down to the upload, you have seen this several times if you have watched my previous videos. I'm loading it in this case to my Medic Mirror demo environment. And then I have also only filled in these 3 values right now. So I'm uploading the pH value, the ORP value, and also the PO voltage, even if it's not used, it's more for debugging. And this is this JSON that I create is posted to the page pool on my Medic Mirror. And you will see how that is handled when we look at the Python program on the Raspberry. Okay, so I have opened up my Python project on the Raspberry, and we will start by adding the page for uploading the pool information from my Arduino. So I will comment this part here. So /pool is the page for posting the data from the Arduino. And in this case, I only received 2 values here, the pH and the ORP. So I will start with that. And I also have a timer to see when the last connection from the Arduino was. So now we get the data, get it into the structure, and I need to uncomment that part as well. So here is the structure for the pool. It's a lot more variables, but we will use them later on. Here's the structure, pool. And then, if you have watched my earlier videos, you recognize all of this. I have an index page, which is used mostly for debugging, where I show all the different values. So here we show the pH and ORP again. Moving further down, this is the main page, the root of the web server. It's a Flask web server on the Raspberry. And here I will do one more thing. I will add or create a message that will be shown on the Medic Mirror if the pH level is too low or too high. So I will indicate that here. And then we will go down to the return data, which is here. So uncomment that. And you can see I'm returning the pH, the ORP values, and I'm returning the error message if there is any, and some runtime data. So added that to the structure that will be returned to my HTML page. So looking at my HTML page, we have the class for the pool that I actually had before because I was showing the TELDOS information and if the pool pump was running or not. So, but I will uncomment all of the data here now. This, and if we have a look at this, it will show a bit more information. It will show the pH error that we created, and it will show the, depending on this error level, we will highlight the pH value in red or orange or blue if it's okay. And I will do the same with, let's find it where do we, yeah, the ORP value here. So basically just showing two more values here on the page at this point. And we will try this. Go to my demo Python project. And I execute it directly from my Visual Code remotely. So let's get that started. So the Arduino has started sending values to the Medic Mirror. Let's see here. It's uploading. And here to the right, you can see the initial pH values and the millivolts that will change. Oh yeah, there we go. So I'm simulating the value of 7.5 and 687 millivolt, and that is really within the parameter. 7.5 is fine, and 687 millivolt is also fine. So depending on the values here, I will visualize it with just the colors red or orange to indicate it's something off. But both these values are showing okay now. Excellent, that works. So on to the next. So here you can see the main board. It's of course an Arduino IoT 33 Wi-Fi and some converters for the sensors, analog digital converter, relays for controlling the water valve and so on. It has also a display connection. So you can see the display here. It's flickering a bit, but this is an OLED color display showing some of the current values. So I have two calibration fluids, one for pH 7.01 and one for 4.71. And I buy them in packages like this, so it's really easy to buy online. And you can also buy like cleaning fluid and storage fluid if you need that. And the first thing I do when I calibrate is that I start with a 7.1. I take my sensor. And I need to wash it off with some distilled water. That, and then put it in. Leave it for a minute. So here we can see that values are coming in, and I want to catch my current voltage and current pH. I'll stop it here. You can see the pH voltage 1467 and the pH 7.11, so a bit high. I left it there for 5 minutes. I think this fluid is actually getting old, so I would get some new. Now wash it off again. Yeah, doesn't look too good. Let's try it. So now we have the acid voltage. I want to do the same thing here. I want to catch it, and it should be a bit off as well. You see here, 1968, 4.22. So I need to adjust it a bit here. No major things, but some small adjustments. Need to update my calibration values, and that's what I'm using these variables for here. So my neutral, pH 7, will be 1467. And for the acid voltage, which is pH 4, have 1968. That's all I have to do. Download it again to the Arduino and up and running and calibrated. So